Good evening, folks. I'm glad Brendan has primed you folks pretty perfectly for most of the buzzwords that are in my talk. So thank you for meaning I don't have to explain them all. Who am I? I am a security and infra person at a startup just up the road. Before that, I ran and secured many banks. And now I work on generating software. So I'm here to tell you folks not how to do your jobs. I am here to give you folks a bit more of an idea of what's behind the curtain on a bunch of these tools. I'm trying to dispel some of the magic aura around large language models, some of the techniques around them, some of the terminology around them. And I'm also hoping to show you folks a technique that I've seen used in high-pressure incidents and also during really boring drudgery. And I'm hoping that that will, help you folks a bit more. So on that point, who here knows what retrieval augmented generation is? Not what it stands for, what it is. Okay, 3, 4 folks. Okay, who's using language models in their day job? Hands up, hands up, hands up. Keep them up. Now, how many of you are meant to be using them? Actually, don't answer that. But yes, so to that point, if anybody's wondering what you should consider before approving a language model, what types of language models to approve, happy to talk about that down the pub. That's not this talk. So with all of that out of the way, and my timer telling me I'm an hour 47 over, I've got a wee scenario for you folks to explain how you might use some of these techniques. So you're a security person and you've just found out that system that you use has a debug API if it was turned on in a specific month. And you're wanting to know, how vulnerable are you? How many of these machines are out there? Is this a thing where everyone needs to put down their tools? Every team needs to stop and scramble to fix this, or is it a limited number? Things like this come up all of the time. So you're going to need to query, well, hopefully for the scenario, you've got an asset database. So you've got some level of inventory of what's actually under your control. And you're trying to work out, okay, am I affected? Am I not? If I am affected, how bad is it? So last time that you did something like this, it took you and your team hours because it's a new tool. You're not very familiar with the syntax. It's a weird flavor of SQL. And on top of that, all of your old examples were for cloud vendor A, and this, the problem is actually over in cloud vendor B. I'm hoping this feels familiar to a few folks in the audience. This has happened to me far too many times. So you've got some tools. You've got your inventory system. You've got some runbooks for that other vendor, and you've got an approved language model. For this demo, all of this is going to be running on my laptop. Yes, it is a live demo. Yes, I am going to be cursed by the gods, but we're going to give it a go because this organization is very careful about their data privacy, about confidential information. As I say, my background is in banking systems. So I want to show you don't have to be sending all of your information over to another company that's perhaps domiciled on another continent, et cetera, et cetera. There are a lot of things that you can do with your own equipment. That does not mean they're as jazzy or as fast, but there's still a bunch of things you can do. There are useful things you can do. So we've got the situation. We want to know, how bad is the problem? Everyone's going to have a different approach for this. I'm sure a number of you in the audience are thinking, oh yeah, last time I did this, or I'm going to do this. I'm just going to show you one way. Again, you folks are the experts, particularly for your own fields. This is just another way of approaching that problem. Do what's best for you. So a lot of talk about large language models. Here's what they are. Souped up autocomplete. Glossing over a few details, but souped up autocomplete. So another term you might have heard is retrieval augmented generation. In fact, your tool is actually doing that. This is a technique for using large language models, and I'm going to give you an example of a cookbook. So you're wanting to know how to make banana bread, but you want it said like a pirate. So what are you going to do? You're going to send over the query of how do I make banana bread as a pirate, which I forgot to put in these slides, but we'll ignore that. And that's going to go over to what's commonly called a vector database. You can think of this as your cookbook. It's wanting to bring out things that are most relevant for your query. So it's going to bring out, hopefully, a recipe for banana bread, hopefully a recipe for rum, you know, things like that. And it's going to send those back to the system, which then parcels all of that up, and it says user wants banana bread. Said like a pirate, here is a previous example of a recipe for some rum and for banana bread. That then all goes over to your language model and hopefully comes back with something sane. None of this technology is actually required, which is what I'm going to show you next. Does anybody have a quick question on this? Sam, did anything come in? So no, I've probably gone too quick. Okay, you're skipping to the demo. Yes, I will prove it to you. The question for online was, surely you need all of this all of this infrastructure, and I'm saying no. The demo will show you don't need it. So we're going to a little bit more information on the scenario. So we're back to the scenario. We have got a runbook for vendor orange. It's for the wrong time period. Vendor orange has a completely different data model because they're not virtual machines, they're instances. And other, you know, fun and games, which just really trips you up in a high-pressured situation. It's the same sodding thing, but for reasons they have chosen to layer it up differently. So now what we're going to do is a live demo. And for that, I need Zoom to work with me. Yep. But before that, I need to make this small. Share the entire window. So what have we got here? On one side, it's fine. We'll be fine once we get started. Yeah. Okay. Thank you. You're going to get to see behind the curtain for this one. So we have our database on the left. We have a language model on the right. Thanks, all good. So for this, we are going to be using the Qwen 3 language model. This is released by Alibaba. It is an open weight model. What does that mean? It's like a binary you're allowed to monkey patch. They don't provide actual source data, but it's a lot more open than some other models. I have just chosen it because for my demo, it works. It's running on this laptop. I'm using a thing called Ollama, which was name checked earlier. You can use things like Jan.ai, which I spotted on Sam's desktop whenever he was sharing earlier. Use whatever you want. Kind of doesn't matter. They're all much of the same, open source. And in terms of the pretty UI I'm trying to use, I'm using a thing called Open Web UI. So what data have we got? So we have our, so this is the Cloud Asset Inventory System. Zoom is doing a wonderful job of reading it all, but that's fine. We have 173,425 virtual machine images, and we have 205,251 VMs. Going through this by hand is not going to work, not going to happen. I suspect a number of you have been in situations like this. This is not feasible to do by hand. The schema is a bit fiddly, a bit awful. It's some weird syntax. So this is SQLite 3, but again, all of these systems have their own thing. So we're going to go and ask our model a lot of stuff, which I will paste in. And while it does inference, I will explain what there is in the prompt. Yes, please. Thank you very much. So for this, Zoom isn't in the way. So structure of this prompt, I'm starting off by saying, using the information below, make me a SQL query for the SQL syntax that I'm using. I want it for these dates. I want it for the red vendor. And I want it to be affected virtual machine image up in the top right. Next, I'm saying only use things in the schemas below. This is not an anti-hallucinogenic thing for the models. It's more focusing it in on these are database schemas. Like it's focusing the model. You're talking about database schemas. Give me SQL. Please don't leak which models these or which vendors these are supposed to be, because this is an agnostic demo. And here is the piece from my other runbook already. And then after that, here are the SQL, here are the table schemas of the tables that you've got. To go back to our cookbook example, I've told the model, here's what I want. Here's one existing recipe, and here's how to do rum. Again, I didn't need a vector database. I didn't need some advanced tool to be able to like auto-magically pull this in or anything else. I can craft the whole thing by hand. And that's the key takeaway I want you folks to know. And this will work much better for giving you the output that you folks are looking for. These models are not all-knowing. They're not trained on everything. They don't know what's in your databases. They don't know what your teams are called. They don't know what your business units are called. They don't know what your priorities are because they're mauve and what that means. The way to think of working with these models is if I package this up as an email and sent it over to an expert in the field who doesn't work with me, could I get something useful back? That's the way to think of it. That's the way to think of your prompts. You probably are under-specifying what you want out of the model. So yeah, as you can see here, this is quite long. And the other thing, before I copy out the SQL and we find out whether this works, keep the message chains with the models focused. If you're doing one thing, do one thing per chat. If you start meandering or talking about different things, different tables, unrelated data, start again. You'll get much, much, much better performance out of the models. Now the moment you folks have been waiting for, let's run some SQL and see whether it detects our 112 vulnerable instances. Ta-da!
The thing is, if you're under government regulation, we're not allowed to use Alibaba.
Yeah. So just to repeat the question for online. Yeah, thanks, Sam. The question was, under government regulations, you may not be allowed to use Alibaba. The point is, I could have used, so this is running entirely on this laptop. In fact, the plan had been not to even be internet connected. This was meant to be an entirely offline device, but I need internet so I can send to Zoom so that all of Sam's incredible work pays off. This could be the IBM Granite models, which are entirely open data, open weights. It could be the Llama models from the US. It could be the European models. It could be that one model from the British company that went bankrupt. It could be whoever it is. Again, the quality will vary, but the point is, this is more about how to approach these problems rather than the specifics. So now that we have shown that it could work, let's do the sort of, follow-up investigation that we're going to do. So I'll scroll up on this. I have copied the wrong thing. I have copied my answer, not the question. So that the model is going to cheat now. So let's go back. Right, here we go. So what am I actually trying to do here? I am telling the model, I have all of this data. How can I find something suspicious? Which again is a common thing that you're going to do. If you're trying to come up with detections, you're going, I've got this flood of data coming in. What of it could be, and it's got stuck on. Okay, we'll try that again. This is pretty common for language models, and resend. Cool. While it thinks about it, yeah, so you're providing the model, what do you want to come out of here? And now it's doing something vaguely sensible here. So it's saying, you might have weird machine types. If somebody's spinning up a Bitcoin miner, they're probably going to spin up a machine far larger than anything you normally use. So I'm going to take this query, probably delete some of it, and then let's see if it finds, and it found the suspicious attacker machine. So this is using, again, this font and zoom is not cooperating. What this has found is a machine that is running with a far larger instance size than anything else in the fleet. And it also is running in a zone that is not commonly used. And if I scroll down, and it is actually, yep, unusual zones or locations. So again, a common attacker approach is spin up infrastructure in a region that you don't use, because someone clicking around in the UI is never going to see it. So, okay, cool. The model has actually managed to find something, and it's found it through a bunch of the ways. Now let's do the other side of this that I'm hoping will get rid of a bit of judgery, which is, cool. That worked for the red vendor. Let's give it the database schema for the orange vendor and ask it to do those same anomaly detections. So I've primed the model. I've said, here we go. Here's a set of schemas. Here's the sort of thing I'm looking for. And now I'm saying, now that you've got all of that, give me the same thing, but for the other one. One example where you might come up with this is, say, for example, you're migrating from Kibana to Splunk, or you're going from Laceworks to Cloud Query, or Cloud Query to Wiz, or whatever else, and you've got these hundreds, thousands of runbooks. Migrating those is going to be pretty painful, but you can use techniques like this to speed it up. And again, the benefit would be that hopefully you've got sample data that you can then use to verify that these things are correct. Don't trust these. You will get hallucinations and all kinds of things. You have to test it. But if you're someone like me who isn't particularly comfortable writing SQL or weird SQL variants, it can at least speed up. Like, I can iterate on a query. I can't write a query from scratch. So with all of this, let's see if we got any weird machines over in AWS, in Orange as well. So for this example, everything's in the US, and it has found some machines in US East 2. They look normal. So no, it hasn't managed to find the attacker machine. But again, it has given me a valid thing for what I'm looking for. And now this is where you can bring in your experience to go back in and say, right, I know for my fleet, we shouldn't have anything in the rest of the US, which should only be here, or it should only be these machines, or we tag everything with cost center. Do the cost centers make sense? With that, we're out of the demo, and I will have a bit of a call to action if I can get Zoom out of the way. Here we go. So what do I think your next steps are going to be? And we'll just skip through these. I think you folks are going to be able to make new runbooks based on your old runbooks, and in this way sort of build them up. Another example where these sort of techniques come in, the language models are quite good at following patterns. So say, for example, you have one team that's making excellent runbooks, and you want all of your runbooks to look like those. Put in several examples of those and say, I've got this runbook, turn it into that style. They work much better with that, particularly with following patterns, which is why I primed this model with, here's an example of what I want you to do. Okay, you've generated some examples of what I want you to do yourself. Let's add to that. Let's add to that. I'm hoping you can also use these techniques to accelerate your investigation. So if you're in a time-pressured situation, you're able to use these to at least give you a starting point of like, oh, geez, it's awful o'clock in the morning. How am I going to detect an anomaly here? Give you some pointers there. It's more of a rubber duck than anything else. And you're going to find the language models are limited. As you saw, it got stuck on machine types. It was repeating off every single machine type that existed for that vendor. That's not very useful. Just stop it, cancel it again, throw something in that just says, don't do this instead. All right, so with that, here are the takeaways again. And here are some other resources you might want to look at. Here's some previous examples of converting between data types. And if you are interested in language model, Gen AI native kinds of tools, there is an open source project here, which is attempting to categorize all of these tools. So if you want to see, right, what security tools are using Gen AI, what documentation tools are using this, what testing frameworks, they're here. If you find anything that's missing, please add it. My company maintains this. And again, resources out there, given there's a flurry, Cambrian explosion of tools at the moment to try and work out what's useful for what. And with that, thank you very much.
Thank you very much, Richard, for a great demonstration. I have the first question, if I may. Your prompts seems to be very precisely written.
Yep.
The question is obviously that you obviously use some prompt engineering there.
Yep.
And how many sort of tries did you go through until you found the prompt which you think works the best? And obviously because you use Quen model, do you find that you need to adjust prompts for different models to achieve what you are trying to achieve?
Yeah. So second question first. You will have to tune your model, or you will have to tune your prompt. Sorry, you are recommended to follow the best practice of the model you're using. To give one example, OpenAI have trained their models to place a lot of focus on the start of any text that is provided to them. Anthropic focus on the end of any text that is given to them. So again, working out where to put the focus of your prompt is quite important based on model. Macy, one of my colleagues, did a talk around task framing, which is don't tell the model, like, I want to do this. By the way, I want to run it on a potato at the end. Rephrase the entire thing to like talk about the constraints of what you're trying to do. Like the whole way through, we're going, this is an asset inventory system. You're using SQL. You're a security person. We're trying to find these things out. To your first point around how much prompt tuning there was, the original version of this talk used Llama 3.0. I chose to use Quen last night because I felt like it, and it ran slightly better on this laptop. It probably took about 2 tries to get it to do roughly what I was wanting, and then about 6 more to make it deterministic enough to be worth risking for a talk. Generally, the challenge is if you're wanting it done in one shot, you need to put a lot more effort in if you want it to work first try, which I need for a demo. If there's an ongoing back and forth with the model, you can get away with like less precision. And again, if you're iterating on something like this, new conversations are your friend. Like if it can't get the SQL right, if it's just getting the table wrong, start again. Put the schema as a table rather than JSON, or JSON instead of a table, or whatever else. The main thing is short, punchy conversations, regardless of model. No model is good with long context.
No? Okay, let's thank Richard. Thank you very much.